Hello, my name is Shashank and I will be today teaching the very first chapter of class 11 chemistry, that is basic concept of chemistry. Many of you would think that this chapter might be boring as it contains a lot of text. But believe me, as we proceed through the lectures of this chapter, you will come to know that this chapter is very interesting and it will also help in laying the foundation for the upcoming chapters. It will also motivate you to study this very interesting subject called chemistry. Okay. So I will today start with the introduction part. Introduction part mainly includes how the chemistry subject was developed and it was discovered one of the important discipline of science and how it applied to daily applications. Okay. So first I would like you to introduce how the chemistry was developed. So chemistry is not an old discipline. Instead, it was not developed for its own sake also. Rather, it was developed while studying two very interesting things. The first one is the philosopher's stone and the second one is the elixir of life. So first one, the philosopher's stone. You can compare the philosopher's stone to the magic pencil. Yeah, you must have seen that serial in which the sketches were converted to the real things. So here I put a picture of the philosopher's stone. So in the ancient time, people used to believe that there exists a stone which can convert some basic elements like iron, wood, tin, etc. into something precious which he or she dreams of. Now the second one is the elixir of life. Elixir of life, okay, elixir of life is similar to the Amrit which is mentioned in the Indian mythology. It gives a person the power of noble person, a power of immortality. So while studying these two things, chemistry was developed. So let me make one thing clear that these two things are hypothetical and are not developed till date. Okay, now coming to the branches of chemistry, during 1300 to 1600 C, alchemy and iotochemistry, two were the major branches of chemistry in the early times. So iotochemistry mainly deals with the study of medicine, while alchemy deals with the transformation thing from one thing to another. So these two were the most important branches of the chemistry in the 1300 to 1600 BC. Now, the modern chemistry which you and me are aware of, that is about atoms and molecules, that took shape in 18th century in Europe. Okay. Now let us see how India and China, mainly the Asian parts, were keen about chemistry. So in ancient India, chemistry was called as Rasayan Shastra, Ras Tantra, Ras Kriya or Ras Vidya. So these were the names given to the chemistry in India, and it mainly studied about the metallurgy, that is extraction of metal from ore, medicine. So by medicine you must refer to Ayurveda, and daily application thing like cosmetic, glass and dyes. Okay. So these are the pictures of the excavation from the Mohenjo-daro in Sindh, Harappa, Punjab. So this will tell that about the development of chemistry in India is very old. Okay. So this is a very interesting material. This is called gypsum stone. Out of this, gypsum cement is made. Gypsum cement mainly consists of lime, sand and some calcium carbonate traces, CaCO3. Okay. And it is used in the modern times also for flooring and ceiling as a plaster. Okay. This gypsum stone was used in the construction work, and its findings were to reveal that it was used in making buildings and all. The second one is the pottery. So pottery was found in Mohenjo-daro during excavation. So many pottery images have been put here by me. So this one is one short one, this one long one is used for storing things and all. Okay. Now coming to the metals about in India. So copper metallurgy was used, was developed in the early Chalcolithic age. So Chalcolithic age is mainly the start of the copper age. So in the start of the copper age, copper metallurgy had started in India also. And according to Rig Veda, tanning of leather and dyeing of cotton, the method of these two things, tanning of leather mainly refers to the protection process which is used to protect leather from getting decomposed by bacteria. So about these two methods, Rig Veda has described, and it was practiced in 1000 to 400 BC. The next interesting material is this vessel. Okay, so this is a golden gloss. The most special thing about it is right now it is a chemical mystery. Okay, the composition of it is still unknown. It cannot be replicated till date. So it is something unique. Not only that, Shastras also discusses about the common things like production of salt from sea. Kautilya Shastra is one of them, which describe the production of salt from sea. Now, I will mention some scriptures and some references which will motivate you to believe that Indian culture and science are deeply blended. Okay, the first one is the Sushruta Samhita. So, Sushruta Samhita basically they discuss about the salt of sodium, which is called alkalis. Okay, salt of alkali metal. So it is called alkali, like salt of sodium and salt of other alkali metal. Next one is the Charka Samhita. So Charka Samhita has a very unique preparation method which is given about the sulfuric acid, about the nitric acid and the oxides of copper. So preparation of these three things were given in Charka Samhita, and Charka Samhita is a very old book. So you can just imagine how old our science was. So sulfuric acid, sulfates of copper, zinc, and the carbonates of lead and iron were the other things. Now, let us move to the preparation of gunpowder. So, Rasa Upanishada discusses about the preparation of gunpowder also, which was used in the artillery. Not only that, the firework which we see on Diwali and all those things, the preparation of those also are mentioned in the Tamil text. So, this firework was mainly prepared using sulfur, charcoal, saltpeter, mercury, and camphor. Okay, so sulfur is just an element, you must have heard it. Charcoal is just a burnt coal. Okay, saltpeter is a potassium nitrate. Mercury you must have seen in thermometer. You must have studied also in 9th and 10th class about mercury. Camphor is used in Indian rituals and pujas for havans and etc. Now, let us discuss about some of the famous scientists at that time which existed in India. So two of them were Nagarjuna and Chakrapani. So Nagarjuna was basically an alchemist and a metallurgist. Alchemist, as I told you about alchemy and metallurgy. So he was basically expertise in making metal from ore and molding things, one thing into another, or transforming one thing into another. His work, Rastankar, also discussed about the formation of mercury compound. He also discussed methods of extraction of metal like gold, silver, tin and copper. That is metallurgy only. Okay. Now, Rasarvarnam, around 1800 AC, it discusses about the various furnaces, ovens, cubicles, and for different purposes. Those were used for different purposes. So Rasarnavam is basically about furnaces. Okay, so by furnaces, those who not have heard of it, so it is just a heat chamber which can be used to mold metals and other things into daily useful materials. The next scientist is Chakrapani. Okay, so Chakrapani was mainly popular due to his method of developing soap. He developed soap using mustard oil and some alkalis, that is salts of alkali metal, to make soap. Okay, he developed soap also, and also he discovered mercury sulfide. Now I will talk about a sort of encyclopedia thing. It is called Varamir Virat Samhita. Okay, it was composed in the 6th century CE. So the one of the major applicants of this encyclopedia is the glutinous material. This glutinous material is mainly applied on the wall to protect it from natural calamities. You can refer from the Ajanta and Ellora walls. The paintings made on those walls still look fresh after ages, and the glutinous was used on it. And this high level of science achievement was existing in India in that earlier time also. Now coming to dyes, turmeric, madder, sunflower orpiment, and conical. These 4 things were used, and many more dye stuff were used at that time. Turmeric, you know about it, madder, sunflower orpiment, and conical. Some other substances like tinting property were Kamplika, Patanga, and Jatuka. Now, let us talk more about that encyclopedia thing. Okay, so first I referred that it has a method to make glutinous which are applied on walls. The second one is this it has many basic application thing also, like perfumes and cosmetic. Yes, you have heard it right. So perfumes and cosmetic preparation were also given in this Samhita. Now let us move to one more scripture. So Gandayukli mainly describes the preparation of scents, mouth perfumes, bath powder, incense, talcum powder. So you can see that how modern things were also developed in the earlier Indian history. So one of the Chinese traveler, I think, went to India around the 17th century and confirmed that paper was also used in India. An excavation of Takshila indicates that it was used around 4th century. So must imagine how back was paper was used in India, and the color of the ink were made from chalk, which was used on paper, were made from chalk, red lead, and minima. Now let us move to the process of fermentation. So what is fermentation? So I will give you a brief idea about fermentation. So fermentation is basically the conversion of carbohydrates into acids. Those who are not aware about carbohydrates and acid, so you can take my word for the time being that carbohydrate is just something that is sweet, like sugar. You can consider as a carbohydrate, okay. And for the acid word, you can consider that is something sour, like lemon juice. So the lemon juice consists of acid. It is acidic in property. Now Vedas and Kautilya Shastra also mentions about the making of liquors, which was done through fermentation only. Okay. Now Charka Samhita also mentioned ingredients such as barks of plants, stems and flowers, woods, cereals, fruits and sugarcane that was used for making aswas. Aswas means Ayurveda. So these herbal things were used, and Ayurveda was developed using them to cure illness and treatment of diseases. Now I will give you a very interesting element about Acharya Kanda. So Acharya Kanda proposed the atomic theory during 2500 years before John Dalton did. Okay, so he developed the atomic theory 2500 years before John Dalton. Yes, the very atomic theory which explains the matter for the first time. So it was explained by Acharya Kanda before John Dalton also. So an ancient Indian philosopher named that atom as Parmanu. Okay, he in the ancient time in India, atoms were named as Parmanu. Talking about Acharya Kanda, he was born in 600 BC and was the first to propose the atomic theory. So according to his atomic theory, the atoms were eternal, indestructible. So it is the same of the laws of conservation. So you can say that cannot be destroyed, indestructible at the same word. So the laws of conservation of the modern side has references from the Acharya Kanda. It was spherical in shape. Yes, that it is spherical in shape. It is also in the modern theory, and it is in constant motion, and it is supransible. Okay. Now this were the main 5 properties which were stated by Acharya Kanda for the atom. He also believed that different elements have different atoms. Yes, he has also given this classification also. Now coming back to Charka Samhita, it also describes about the use of the bhasma. So bhasma in the modern science refers to the nanoparticle use. Okay, so he used the bhasma for the treatments of ailments. In the ancient time in India, the nanoparticle or the bhasma was conceptuated by saying that it was the reduction of a particle into smaller than smaller size until it is not visible by eyes. So you can say that it is just visualization thing. Okay. Now Charka Samhita is also an old Ayurvedic epic of India. Okay, and describe the treatment of many diseases. Then after the decline of alchemy and iodochemistry, which were the 2 important branches earlier, the modern science took place. Okay, around the 20th century in the Western medical system was practiced. Later on Ayurveda also declined. It existed for some time, but it declined gradually. Now modern science appeared in Indian scene at the later part of the 19th century when Britishers came to India. By the mid-19th century, European scientists started coming to India and modern chemistry started growing. So in today's chemistry, which we and you are aware of, is mostly about the composition, structure, properties, and interaction of matter. And atoms and molecules are considered now the basic elements or the building blocks of the matter. Chemistry is also called the science of atoms and molecules. Now, coming to the modern application of chemistry in our daily life, it is very important and explain many of the phenomena occurring around us. It explains the formation of clouds, rain, snow. Okay, it also helps in studying the neuron system that exists in our brain, because neuron system is nothing just the flow of electron in our neurotransmitter that our memory can be formed. It also helps us to understand the flow of electrons in computers, because computer is based on the semiconductor, and semiconductor mainly talks about the flow of electron across the band gap. So chemistry is also used to study those things. Apart from that, if we apply use daily things like polymers, drugs, soaps, acids, salts, dyes, and fertilizers, detergents, metals, alloys, and many more materials, all those things are an applicant of chemistry. Okay. Now, chemistry has also been used to develop many drugs, and one of the major issues now existing in the world is the cancer. So cancer is just being found in one or other person. So chemistry has also developed drugs for that, namely cisplatin and Taxol. One of the recently developed medicine is the Vitrakavi. So what is Vitrakavi? To understand that, one should know what is cancer. So I will give you a fundamental basic about cancer. So what is cancer? So cancer is just a abnormal growth of the cell in our body. So what does Vitrakavi does? So Vitrakavi just stops the growth of that cell. So how it does? So for the growth of the cell, kinase is responsible. It is a kind of enzyme. You can say that it enhances the rate of growth of cell. So Vitrakavi just stops it from functioning, the kinase functioning, and stops the cancer cell from going further. Now, I will move to the next topic, that is the nature of matter. Okay. So, from our previous understanding and what we have learned in the earlier classes in 9th and 10th, you must have seen these three states of matter. You will be knowing about that. You must have known about that. So that there are three states of matter, namely solid, liquid, and gas. One or two more states have recently been developed in our modern science, but we will keep our discussion to this three. So if you want to know the names, so one of the most known name is the Bose-Einstein condensate. And it is a very unique material and has unique properties. But we will not discuss about this in this class. Okay. So first I will talk about the solid. So what is solid? So if you look around yourself, then you will find that most of the thing that exists around you is solid. Whether you look to your door, whether you look to your house, whether you look to yourself in the mirror also, that mirror is also solid and you are also solid. Okay. So most of the thing that exists around you is a solid. So you must have noticed these two things about solid, that it is at a definite volume and a definite shape. So I will depict it using this example I have given below. So this is a picture of a table. If you look at it, it has a definite shape. That means it looks like a square put upon four legs. So its shape is definite. Okay, its volume is also definite. If you measure the length and the dimensions of this and calculate its volume using metric system, then you will find that its volume is definite and does not change with time or any other substance parameter. Okay. Next one, then how this thing happen? Why does this solid have a very definite shape and a different volume? So you can explain this using the atomic theory. Okay, I will discuss about it later, but now I will just give you a brief overview about that. So if you think of anything that is matter, they are made up of small particles that are spherical in shape, and those are called atoms or molecules. Okay. So in solid, this atom or this molecule, I will say this particles for the time being, these particles are closely held to each other to the strong intermolecular forces that exist between them. So due to this strong intermolecular forces, they have no freedom of movement. Means not much freedom of movement. They move, but not that constantly and not that freely. Due to which they have a definite shape and have a definite volume, and they are ordered. Okay. Now coming to liquids. So liquid, you can simply think of the example water. So water is liquid. The milk you drink is liquid. The oil you put in the vehicle is liquid. So all those things are liquid. So how does liquid differ from solid? So one thing is that it does not have a definite shape. So if you look at the glass which I have of water, it is filled with water. If you look at it, the water took the shape of the glass. Now if you pour this water on floor, it will lose its shape. So by this you can say that it does not have a definite shape, but it does have a definite volume. Suppose you went to the market and bought 1 liter of milk. Now you put that milk in a vessel for storing. So does the volume of the milk changes? No. It still remains 1 liter only. Until you boil it or due to condensation, its volume reduces. It remains same. Okay, almost, approximately you can say. From that as the time passes, its volume changes, but it is not that much. Okay. Now, why does this happen? So the intermolecular force, I will explain it using the same. The intermolecular force between the particles of liquid are weak as compared to the solid. So due to which their molecules are free to move around here and there. So due to this, they do not have a definite shape, but they do have a definite volume, as they have a intermolecular force that exists between them, which is not so negligible to indefine their volume. Okay. Now coming to the gases. So in gases, particles do not have intermolecular forces at all. Means it is negligible. So suppose if a gas molecule, if I take a cylinder and put a piston above it. Okay. Now I apply pressure on it. What does happen? This piston will go down. Okay. Go down, and due to this, the volume of the gas changes. So you can see here the shape of the gas also changes, and the volume of the gas also changes. So you can say that it does not have a different volume nor a different shape, because they have almost no intermolecular force of attraction, due to which this particle move very fast. If you want to see it applicable to your daily life, so when food is cooked in your house, you can smell the food aroma from a far distance. Why does this happen? Because the gas molecules are moving constantly here and there, so they move fastly and you can sense them. Okay. Now I will talk about the interconversion of states of matter. So solid can be converted to liquid, liquid can be converted to gas using heating, and conversely, on cooling, solid goes to liquid, liquid goes to gas. You can see this beautiful phenomena occurring in nature also. So you must have learned the water cycle in class 8. So what does happen? So first the water present in the sea get evaporated and become cloud. Now this cloud again rains, and the water present in the form of gas decomposes or condenses and fall back to the river as in the form of water. So this interconversion is taking place almost rapidly, so that the balance of nature is maintained. Water is also transpirated through the leaves of the tree, and many more sources are present through which water is evaporated to the clouds, and cloud again fall back to the earth in the form of water or rain. Here are some more examples which will help you to understand the interconversion of states of matter. Okay, the first one is the ice melting to water, then water to steam. So at 0 degrees Celsius, water exists as ice, but as you gradually increase the temperature, this ice gets converted into water. On further increasing the temperature, it evaporates and forms the gas. Now, if you cool down this gas will be converted into liquid, that is water, and back into ice. Okay, so this phenomena goes on if you go on it warming and cooling. So this same thing is written here. Okay, so this thing also same. Now I will talk about one interesting thing, that is carbon dioxide gas. Okay, so carbon dioxide gas is basically the gas which we breathe out, but it is used in one of the one interesting way. So if you look in movies, you must have seen that ice is present in around around the scene during songs or scenes. Okay, but many of the time in the early movies, the ice which was used, it was not actual ice, it was just solid carbon dioxide. So it looks just like ice but is not the real ice. Okay, so it was used to create an illusion of ice. Okay, these are the phenomena which replicates the interconversion of states of matter. Now we have talked about the three states of matter. Now I will talk about the classification of matter. So matter are classified mainly into two. First one is mixture, second one is pure substances. So what is mixture? So mixture is just the combination of two or more substances, pure substances, in varied amount. So the amount is not fixed, it is changed accordingly what the need is or what you want to do. So the mixture is something that which has an undefined ratio and of two or more pure things to make a different thing. Now mixtures can be of two types. First one is homogeneous mixture and the second one is heterogeneous mixture. So what is homogeneous mixture? So to understand homogeneous mixture, we can take example of sugar solution. So if you dissolve sugar in water and stir it properly and thoroughly, you will find that its composition become constant. To identify that, you can take a sip of water. The taste of that water remains same on the next sip and on the coming sip also. So whenever you taste, you will feel the same amount of sweetness, which can define that it's uniformly distributed. So components are uniformly distributed. So in a homogeneous mixture, the components are uniformly distributed and is same throughout the mixture. Next is the heterogeneous mixture. So heterogeneous mixture is the opposite of it. It does not have a uniform distribution of its components in the one part or the another part. One of the example you can take is as a soil. So if you look at the soil is not a homogeneous mixture, as the stones, pebbles and sand, clay present in them is not uniformly distributed and it is here and there. Similarly, oil and water. So if you pour water into oil or oil into water, the water floats on the above of water. The oil flows above on water. So what does happen? So at some places oil will be accumulated more, or in some places it will be accumulated less. So its composition is not same throughout the mixture. So it is a heterogeneous mixture. And many more examples like salt and sand mixture, grains, pulses mixture, and these things are the example of heterogeneous mixture. So how can we separate this mixture? So they can be separated simply by physical method like filtration. The filter, you must have installed filter in your house also for pure water. So filtration, the clay particles or the dust particle which are dissolved and are harmful for you are taken out from the water. So you can separate those mixture through crystallization also. So how does crystallization work? Suppose you dissolved sugar into water. Now if you start heating it, then water will evaporate and go to the atmosphere, and what will be remain is the sugar. This sugar will crystallize. So this process is called crystallization. Now hand picking. So in your home, when something is dropped in your grains, which your her or his mother take it out through hand picking. So you can do it by hand. That process is same. That is now the second one. Fourth one is distillation. Okay. So distillation. What is distillation? So in a oil factory, when crude oil is when we get a crude oil, we have to separate it to get wax and petroleum and diesel and many more things. So their boiling points are different. So this distinction between them is used to separate all of them, and the process is called distillation. The second one is pure substances. So what is pure substance? So pure substance is something that has a fixed composition. So if you take an example like water, what is water? Water molecule is H2O. So it has a fixed composition that two atoms of hydrogen will combine with one atom of oxygen to form water. Now, it has the same chemical nature. So it does not depend from where you are picking up the water. The water will have the same fluidity, the same viscosity, the same density at all time. Now, pure substances can be classified further into elements and compounds. Okay, before discussing elements and compounds, let us see some of the example of mixtures and pure substances. So from mixture, we can say the sugar solution in water. So its composition is not fixed. You can dissolve 1 tablespoon of sugar in water or 2 tablespoons of sugar in water. It will remain sugar solution. But since its composition is not fixed, it is a mixture. Second one is air. Yes, the air is not also a pure substance. It is a mixture. It is a mixture of many of the gases that exist in our environment, like ammonia gas or the nitrogen gas or the oxygen gas. They are present in environment and they are not uniform also. Their distribution is ununiform throughout the atmosphere. Tea, solar, soil, and all these things are mixture. Now coming to the pure substances. So pure substances are those which whose composition are fixed. Like if you take sodium, its composition is fixed. You cannot say that okay, sodium and Na will be present in different amount in different metal. Okay, copper similarly silver, hydrogen, oxygen, and carbon dioxide. Many more pure substances example are given here. Now coming back to the classification of the pure substances, there are mainly two types of pure substances. First one is the element and the second one is the compound, which we will discuss later. So what do you mean by element? So element mixture is something is that which have the same constituent particle which comprises the mixture. Okay, pure substance, you can say it more specifically, pure substance. So in the pure substance the constituent particle are same, those are elements. So suppose we take an oxygen molecule, so it will be an element. Now how it will be an element? It is composed of two atoms of oxygen. Since atoms of oxygen are identical to each other, so it is an element. So this element can exist in two forms, atoms or molecule. So if you take an oxygen molecule, it is also an element. If you take an oxygen atom, it is also an element, because the constituent particle are same and not different. Now some of the other examples of element are sodium, copper, silver, hydrogen, oxygen. So sodium is basically sodium atom, copper is copper atom, silver similarly similar, hydrogen and oxygen. Now coming to the compound. So compound one of the most important distinction between these two are the element can also be atom or molecule, but constituent particle of the compound should be same. Okay, but for compound it is not so. In compound it can be only molecule, because you have to have two different things, and two different things can form a compound only and not an atom. So some of the example are carbon dioxide, glucose, water. So you can see here the glucose, which is a complex molecule, but its proportion is fixed. Yes, one thing is obvious in both, because it is a pure substance, so it will have a definite composition. It is mentioned here also that it is made up of elements combined in fixed ratio. Okay, so here in carbon 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen combined to give glucose. So the composition is fixed, but different elements are used, or different pure atoms are used to make one compound. So it is called a compound. I put up an illustration here to explain this element and compound thing. Okay, so this all are elements. So this one has hydrogen atom, oxygen atom, nitrogen, copper and sodium. So this all atom, if they are independently, if we take them independently, they will make an element only. Now if you combine two hydrogen atom and make one hydrogen molecule, then it will be also a element, as the constituent particle are same. Similarly the oxygen molecule will have two oxygen atoms, and so it will be an element. Now coming to compound, this is the picture of a water molecule. It is a compound because two atoms of hydrogen and one atom of oxygen, two different atoms you can say, are combining to form this one water molecule. Similarly, this carbon dioxide molecule is formed by the combination of oxygen and carbon, and not just one atom. So this is a compound. Let us brief the properties of compound. Okay, the first one is that the two atoms, different atoms, should combine in definite ratio. Then only a compound is formed. And those compounds have a fixed composition. The similar thing is written, the different ratio or the fixed composition. Okay. Now next, this constituent cannot be separated by simple method. Yes, it is true. You cannot remove hydrogen and oxygen just by any physical method so that you can get hydrogen and oxygen out of water. You have to go through a very critical scientific method to do so. Okay. Now, the properties of a compound are different from those of its constituent element. Yes, it is very true. So suppose a water molecule is formed from hydrogen, but if you look at hydrogen, it is gas, and if you look at oxygen, it is also gas. But the water formed from it is not a gas; it is a liquid. And not only its physical properties, but all its chemical properties are also very, very different. Whereas hydrogen is very less reactive as compared to water molecule. Water molecule is somewhat reactive. Okay. Now, I will end this lecture by giving you a table that will make easy for you to divide the matter into subdivisions. Okay. So, primarily matter will be divided into two things. First is mixture, second is pure substances. So, what is mixture? So, mixture is something which has two pure substances dissolved in not definite amount, whereas pure substances can be anything, just it will have the definite composition. Okay, it can be singular, it can be plural, but it will have definite composition. Now the mixture can be further classified into homogeneous and heterogeneous mixture. So what is homogeneous mixture? So by homogeneous mixture, the composition should be fixed throughout the mixture. It's like if you take sugar solution, stir it properly, then the sugar will be dissolved thoroughly through the water. Coming to the heterogeneous mixture, you can think of air, which has the different type of gases, and the gases present in one part of the atmosphere is not similar that the gases present in other part of the atmosphere. So it is a heterogeneous mixture. Now element. So what is element? So element has something which has a definite proportion, but the proportion in which the things are dissolved, the things must be similar. It can be singular also, it does not need to be plural. So you can take one element like oxygen, just the oxygen atom, it is also an element. If you take two oxygen and combine it, oxygen molecule, it is also an element. Now compound. What is compound? As I have discussed earlier, so compound is something in which two things combine in definite proportion, but the two things are different, like hydrogen and oxygen combined to form a water molecule, carbon and oxygen combined to form carbon dioxide molecule. The one more important thing, that elements can be atoms or molecule both, but compounds are only molecules. Okay. With this, I would like to complete my lecture on the first lecture of basic concepts of chemistry. Thank you.